Ladies and gentlemen, I'm Jeremy Bennett. This is a bit of an experimental first for the LLVM. It's a panel session, and we have one throat microphone. It's intended to stimulate a discussion. Quick show of hands, how many people here have worked or are working on LLVM? And I'd include in that anything in the LLVM toolchain. And how many people here are working on GCC or anything in the GNU toolchain? Okay. How many people here have dipped into or are dipping into both? So actually there's a number. The point is there are quite a few people who work or have worked on both projects, and it's possibly time we try to work out how to work better together. We had a first session at this at the GNU Tools Cauldron, and you can go and watch the videos online. The link is on the abstract for this. But we wanted to go into a primarily LLVM audience, and the LLVM Foundation suggested that FOSDEM was where you were going to find the broadest spectrum of views, unlike not in California. And so that's what we've got. And we have three panelists to lead the discussion: Arnaud de Grandmaison, Pedro Alves and Tom Trome. I'm going to let each of them briefly introduce themselves, and then what we're looking for is a discussion about how we can work together, and in particular afterwards we'll look at the recording and see if there are some concrete ideas of things we can actually take away and do, rather than having a nice comfortable chat about them and then nothing happens. So here's the aid memoir, and we can cover anything else. It's not just GCC and Clang LLVM, it's the whole tool chains, LLDB if you're LLD, GDB, binutils, and so forth. So without further ado, let me ask each of the panelists to just say a couple of words about themselves.
Hi, my name is Tom Trome. I work at AdaCore primarily on GDB, but in the past I've worked on GCC, and I also worked on Rust for a while, so I've worked on LLVM and LLDB as well.
Hi, my name is Pedro Alves, and I work at Red Hat on the debug team, and I've been working on GDB for a while, and I'm a GDB maintainer and contributor.
And I'm Arnaud de Grandmaison. I'm working at ARM. I spent a long time in the compilation team at ARM, working on LLVM. And before joining ARM, I was in startups doing on custom DSP, working on a custom DSP and a custom processor. And there I was in charge of the tool chain, which was obviously LLVM based.
Can you speak up louder?
No.
Because if the mic doesn't go to the...
Okay, it just goes to the camera. Okay.
Should we start over?
Okay, so this is intended to be a session where everyone participates. The three at the front are to stimulate discussion. I've put up, on the basis of the meeting we had at the GNU Cauldron, some areas that I think matter and where we could work close together. Language standardization, ABI compatibility, interoperability between the tool chains, and also channels of communication. How do we talk together? Do we need different conferences and so forth? What I'd like is each of the panelists now to give their first thought on the one most important thing we could do to improve cooperation.
I should have expected to be on the spot. Yeah, I'm very bad at planning. My primary focus is on debugging, so that's what I know the most about. And when I look at the debugging world, I think it's actually in a worse state than like the sort of the user language world, like writing C or C++. And I think that one thing that would be very good to do is to have GCC and LLVM sort of explicitly cooperate on improving the dwarf standard and documenting and sort of standardizing the extensions that they both use. So I think that would be a very fruitful area for cooperation.
Wow, you've said everything. I come from a debug background as well, and actually my work on the compiler side is not very meaningful. Looking at the current state and current like duopoly in the debugger land in open source, I see two aspects that would be nice to improve. And one of them is an area of focus right now for our group. It's on the quality of the bug information. We've been looking at the quality of the dwarf that the compilers emit. Does it represent the original source accurately? Does it support the whole set of dwarf, the whole features? Which compiler emits correct output? Which one doesn't? Which one needs to be fixed? It would be nice if we joined efforts in the testing side, in the testing frameworks that validate the quality of the bug information. I know that there have been efforts on the LLVM side about this. It would be nice to chat about it. And that was the second point, which I forgot right now. What was it? It will come back. Sorry.
Okay, so it's a bit hard to be in the third position there. But so maybe to differentiate a bit, but I think it tightly links to what you've said, and I think where we could probably better cooperate as communities is around the language standards. My understanding of the language standards, or the standards, because if we consider dwarf as a language or not, I don't know. But the thing is, my impression is that mostly in the standards committees, companies are represented, and whether this is LLVM or GCC, this is more tools for experimenting with the new standards. And but this is not representing the whole GCC or the whole LLVM community as a whole. So I don't know if I'm right there. But I don't think we have LLVM only representative or GCC only representative at those standards committees.
So, on kind of a tangent that touches standards, again from the debug side, because that's my expertise. For example, there's been a push on LLVMs for OpenMP support, I think. And yeah, I'm sure. And for debugging OpenMP, there's a standard called OMPD, which is OpenMP debugging. And that requires implementing a library that exposes the standard interface. And what's happening right now is that LLVM is implementing that library, and GNU side also needs to implement something like that, exposing the same library, and other tool chains like the Intel compiler also is doing the same. And we have a mixed match of a matrix of debuggers cross runtimes, like GDB against the LLVM runtime, GDB against OMP from the GNU side, and LLDB against GCC, and the matrix. It would be nice to see about sharing that infrastructure, maybe sharing even the code, and that can only work if we cooperate and discuss and experiment together. And the other point, which I had forgotten earlier, came back to me. It's I wanted to mention like LLDB uses the remote protocol from GDB, and it has its own extensions. And it would be nice to cooperate in the sense of ones that are generically usable would be standardized and documented in a single place. And the longer we take to get to that point, the more we will end up diverging, and we don't want to end up in a place where tools end up more incompatible. Sorry about talking only about debug stuff. But
Okay, thank you. At this point, I'd like to throw out the same question to the assembled multitude. If you'd like to put your hand up so we catch it on tape, if you make your point, I will try and summarize it and repeat it. So from the audience, anyone here have a view on the most important areas where we could improve cooperation between GCC and LLVM? You're right, I can give you the microphone.
I think somewhere of a neutral forum for discussion would help, in that you've got a set, so basically LLVM mailing list, you have GCC mailing list, you can be known in one and not the other, and there's sometimes intimidating to cross the gap. So I say more places where you can sort of tread on a more neutral place.
Okay. And, yeah, if you just say it, I'll repeat it for you.
I do not know if it's already done, but GCC has a very big test suite of accepted tests by the GCC community. We could throw together the tests for maintaining code quality.
So the suggestion is that GCC's big regression test suite could be brought together and have it as a test suite for LLVM. I have to say that professionally, we've been doing that for 10 years. So it's there, but it will be good to formalise that so everyone can pick it up. They don't have to come and get our magic copy of it. Any other comments?
The torture tests have been integrated a couple of months ago into LLVM tests.
Excellent. So we now have some of those there. So that's great news. The torture tests are there. Which are the ones that cause pain?
Well, let's talk about that for a second. I'm really curious about this. Like I know GCC incorporates some things from LLVM, sanitizers or whatever, and those are just imported periodically, and maybe there's local hacks, I don't really know. On what basis are the GCC torture tests integrated into LLVM? Do patches go back to GCC? You know, is that, because I feel like this is an important thing where I feel like for instance, this thing about cooperating on Dwarf, which is territory I'm really comfortable with, right? Like there, part of the process has to be like a social commitment by the maintainers to say, if you're going to extend the Dwarf, you have to follow our agreed upon thing. You have to upstream it or document it or whatever, you know, but that requires like a commitment from both sides. But, you know, I'm concerned, like, just hearing that, and if you don't know the answer, like, is it a fork of the GCC test suite? That, to me, seems like worse somehow, you know? It's a bad outcome. Yeah.
I didn't do the work, I'm not sure.
I mean, you know.
I believe it's actually it is a fork, and it works by actually having a blacklist of tests that won't run. That's been done once before, and of course then people end up running a 10-year out-of-date test suite. So I think there are two good points there. One, it's good that the cooperation is happening, but the second is actually if it just leads to another fork, then it's possibly not long-term valuable. More comments from the assembled multitude?
Yeah, I think one thing that works well that I see occur sometimes between projects is just practicing careful communication and respect kind of thing. It's very common for people, like I try to dissuade people from saying, oh, why was this implemented this way or not that way kind of thing, and generally be respectful of the competition, I think helps in all discussions on either sides of things. One thing that I wish we had more of was like an RFC proposal would be interesting for certain language extensions that like right now, either side will ship extensions without input from the other and not necessarily take these to the ISO standards bodies. And I think that's okay, but then typically multiple implementations will work out different kinks or interesting edge cases, or things don't compose a certain way with other features. And these typically only kind of shake out once you get more than one implementation.
I wanted to, you can repeat it out, one plus that part, the last part that we talked about, but also a person who has to write code that compiles with both tool chains. It usually becomes very difficult from a documentation perspective, trying to figure just that thing out. So if some user of our code actually writes some code based on an extension by GCC that goes into this larger ecosystem, trying to figure out like the rest of the components will work okay with it. It's just a nightmare right now.
So the comment being made is that if you have divergence of extensions as part of the language exploration, then people writing application code have a nightmare of making sure it works on both GCC and LLVM.
Sorry. Just about the documentation thing, I think one issue there is, so if you work on GCC, you're familiar with GCC, and if you work on Clang, you're familiar with Clang. There may be no one who can write that document who understands the subtleties of the divergence in some particular feature, But I really liked your point, and it really reminds me actually of like what happens in the web world where, different browsers collaborate and features sort of don't become web standards until they're implemented in multiple browsers. And they have, like you said, more or less an RFC process. And I think that would be an excellent idea.
Well, so on the RFC process, maybe one thought I have of where it might get hard to implement it is that the more people you involve into a discussion, the longer it takes, and it seems sometimes. I've seen in the past incompatibilities between two tool chains appear because in one community there's a quick need to implement something would be relatively straightforward, and in the other community they don't see the need as quickly, and so one community moves ahead because there's a genuine need for it, and the other community doesn't react as quickly. So that might be something to overcome, maybe not necessarily completely impossible. From my point of view, I would say my personal experience is I find most of the difficulties to come from probably the ABI side, in that whenever a new feature gets implemented, quite often without realizing, there's some small binary interface all of a sudden that gets created, and it sets as a de facto standard, and it doesn't get documented. Maybe that's because I work more on back-end side stuff, and it's just, it seems almost, probably every week, at least every month, some small extra addition happens to a binary interface somewhere. And I would say the majority of binary interfaces go completely undocumented. And so I'm starting to wonder, would it make a difference if we tried to recognize, oh, there is a new binary interface that's at least just documented, so it becomes more visible, and it's not just 3 people who implemented it, and you have to reverse engineer from code. Would that be helpful?
I have the impression that just documenting it would not solve it, because when it's only when the other team goes and tries to implement it, even based on documentation, that they realize, oh, this corner case wasn't considered. And it's only them that will notice it, because the original team just implicitly thought it worked that way, didn't even think it would be a possible design point change. So it feels to me like a lot of this is going to be based around communication and just reaching out and being friends, making bridges, and break away from that mindset of them versus us. We're all just toolchain people who work on the same kinds of problems, and we should, I'm adding this extension for the C language. I should reach out to that friend on the other side and see what he thinks about it, and hash it out a little bit, at least, in public, in preference, and make that a way to shake out some things before they are done and documented it. And then what frequently happens is it's released and shipped and out, and only a release later is the other side aware of, oh, there's an extension for that. Let's try it. And then it's already too late, because it's already in the wild. So the point is, just reaching out.
And to build on the point you raised earlier on, and also on what Christophe was saying, with the fact that the two compiler teams may not be working with exactly the same agenda for different reasons. I think what would really be important, apart from having some documentation for the ABI, would also be to have some tests, because just the description of the ABI is often not enough. ABI can be quite subtle, and the corner cases are not often not described in the specification, or why you are doing things this way. And so there you really need tests.
That's an excellent point. That's An excellent point, and it's something that you can do in your own team without reaching outside, right? And it feels to me like that's just
Good
a
engineering
good
practice.
engineering, right? If you're not doing that, you're doing it wrong.
Okay. I've got a question at the back. Patiently waiting. Patiently waiting.
This is a bit of an heritage question. I'm sorry for that. But, Microsoft has been also starting to open source stuff like the C++ library last year. Are you planning to involve them also in these discussions as this for C++ and our compliance? Because it will make it work so much better for us developers.
So the question was the small device. There's a
Oh, the standard library of Microsoft has been open source last year, so do you plan to involve them in this standard discussion?
It's a very good question. So Microsoft have open sourced their library last year. Yes, I mean I think the whole point is to bring in all voices. Microsoft is changing. They were at the GNU Tools Cauldron this year, which I think is a first and a very positive and big support. They are changing as a company, and yeah, of course, the more the open, the whole point about free and open is it's inclusive. That's great point. Yeah, two questions here.
So that's somehow related to specification and testing, but writing tests is not the most tremendous task or the most enjoyable task. And whenever we develop a new security feature or a new optimization, we could write the tests as a whole community and in a generic way, and then everybody could implement it and take advantage of the test suite. That's some area where both from an engineering point of view and from a time spent point of view, collaboration is fruitful and not very difficult to set up. I had wished that for 45 stores there would be a test suite that I could use.
Okay, that's a good part. From my personal experience, I know the GNU regression test suite is based on Deja GNU features that say, is this feature supported? And if you write those generally above, you can give them GCC or LLVM and it'll work out whether the test can run. The problem is the GCC test suite is huge and very old, and only the best and newest tests actually work like that. So the real world hits a bit there.
I have a similar question like Sesh. He made a talk about changing the compiler from GCC to Clang, and I saw many projects that try to standardize, don't use GCC specific stuff, and I think it would be great as a user to have more interoperability. So where I can just change my compiler without having to think much, and I think it goes currently the other way around. That some projects just require to use Clang, and if I have a platform that isn't supported by Clang, I have no chance to do anything, and yeah, it would be great as a user.
Here, I'd like to say that on one hand, interoperability is a nice goal to have. The other thing, I mean, if you try to do embedded software, it's often a good idea to test it with multiple compilers because they will make different implementation choice, and you need to accept that what you have written is not portable. So I mean, that's the point of interoperability. It's just a subset will be interoperable. So that's, I mean, it goes both ways. So yeah.
I'd like to ask the panel what they think about deprecation as such, or at least not deprecation, I'm talking re-implementation. So if, like it or not, all the calls for collaboration, there will be features that get pushed ahead further in one than the other, and then the other will try and catch up as such. Is it sort of, in some ways, it's akin to code review? You do something downstream, you then move it upstream, and it gets code reviewed, it gets changed. And is there a way of deploying newer features as maybe some kind of tentative extensions, or is it anything that you put in binary for life? I guess is there rule for, say, communities to introduce things as sort of, okay, you can use this, but it's not standardized yet, whatever, it may change in the future, that type of thing.
That's a good question. I think we ought to ask the panel, and I'll start with Arno this time.
So I'm not sure I understood fully your question, but so around for the deprecation it's a bit hard because as long as you have one user who does not, who stubbornly refuses to upgrade his code base, you cannot fully deprecate the stuff, or you will have to stick with an old version of the tools.
I'm far from an expert on the compiler side and the runtime side, but there are some things that have been deprecated. Like I'm thinking, for example, on the glibc side, there are facilities to, if you really need to, you can create a new entry point and use. Help me, Mark.
Symbol versions.
Symbol versions, exactly. Thank you. To like. The old binary will still run and link at load time with the original deprecated version, but if you try to compile again the program, it will be using the newer ABI entry points. So it's possible to deprecate things on the runtime side. On the compiler side, I'm not sure what the answer is. I kind of feel like if it's there there forever.
Ask Serge. I'm sure he may have found some compiler flags which are dating from very, very old versions of the compilers.
Okay.
And the compilers are just ignoring them just so that the build scripts don't fail.
Yeah, GCC does that.
Yeah, GCC does that, but that's not specific. And it's not specific to compilers. I mean, LS has obsolete flags, and they are still there and used, and just an up. So that's common practice.
Although software was named soft as opposed to hardware. Once in there, it becomes a hard stuff.
Yeah, that's the command line aspect. And on the coding side, on the language support side, is there any
when we will get rid of C89 or before?
Yeah, in 40 years.
Maybe.
So I think I think one thing is you have to differentiate between like the different cases of compatibility. Like for source language, in a way, it's easier to just say we will no longer accept, K&R declarations or whatever. Those are just errors now. I mean, I don't know if they are. I'm just saying it hypothetically. And then people who want to have a 30-year-old C compiler should go find one. What's hard is ABI compatibility, especially if, what happens pretty commonly is someone implements the ABI and they think they did a good job, but they made a mistake and it's not found out till later. And then if you think about it, like if you just have one tool chain, right, like GCC made a mistake, well, they think it's better to just leave the mistake. Yeah, now it's the standard, yeah, even though it's ridiculous, right? But it's more difficult when there's two compilers involved because you can have this thing where you have parallel implementations and one or the other makes a mistake, or they disagree about what's a mistake, or, it's undocumented, and so they both made a choice, and even those cases can be treated differently. You could say, well, as communities, we'll have a commitment to following the standard. So if you catch us in a mistake, we'll make our users suffer a little and change. But that has to be like a two-way street. Everyone has to agree to that, as a social thing. And then for the case of implementing a new feature, like it's not documented and you want to make some choice, you have to also, make it it's a social problem. You have to say, we'll commit to sending a note to some ABI list to say, hey, this is what we're planning to do. Stop us before, we strike or whatever.
Sure. Yeah, question, I guess, to Peter, to reinterpret your question, were you asking more about how could we possibly ship experimental features with thought of potentially deprecating it in the future?
Yeah, so I'm thinking less about, say, for instance, thinking about implementing things that are already standardized, like things in the front end. I'm thinking about, say I've got some new binary security feature. So I'm just going to pull stack protection out of the hat here, and it will work in a certain way in a compiler. That's a downstream binary thing. The compiler can choose how it implements it. But it has, as Christoph mentioned, some form of ABI. then when, say, Clang comes up to that, does it need to match precisely? It might not be possible to match precisely. At the moment, I'm talking about for things like that that are kind of not in the area of anything that's really written down. How do you get it so that, say, for example, you can maybe transition to a form that both can accept, and that might involve changing. And I think partly it's also got to be driven by the community. I think when there's demand from users that Clang and GCC work together, they will do it. When there's not demand in areas that nobody cares about, it's not going to happen. So I think a lot of it's will be to the community to decide what happens.
So yeah, one of the reasons why I remarked trying to produce some documentations if you realize you're introducing some new binary interface, even if it's a small amount, was just to try to make it a little bit easier for other projects to start using that interface. One thing so it would indeed be really nice if we could come up with introducing binary interface without from the start it being forever, making it more evolvable. I don't think there's an easy way to solve that problem, and the only partial solution I think maybe for some binary interface might help a little bit is just try to make sure there's always some kind of versioning there. So if you need to change, at least it's very easily detectable. Something like that might be one step in the right direction, but then it would need like general agreement. Oh yes, every time we recognize we're introducing binary interface, we'll make sure there's some metadata somewhere, easily interpretable, records a version, something like that.
Thank you. At this point, we're quite a long way through our discussion. A lot of issues raised here. I want to turn to solutions. Now, we've had one suggestion, which is for having a neutral mailing list, so you don't have to, that is neither GCC nor LLVM for discussing neutrally. That's a good one, I think, to take away and see what is the organisation that can host such a list that will be trusted and respected. We can take that one away. I'd like to now open up to the panel for solutions. We've got one LLVM director here. I don't think we've actually got her GCC steering committee member, have we? No. But start with you, Pedro. Solutions.
Oh man. Start from scratch.
Third compiler.
Yeah. The solution new standard, right? I don't know solutions. You were mentioning ABI versioning, and it reminded me of work that Red Hat is doing, and maybe I'll ask Mark Wheeler to help me with this. The Nix project, what's the name of that? The binary tagging thing? No, not that. No, that's Doji's. Nick Lifton's Anobin, exactly. Can you talk a little bit about that? See what I've done there?
Tell us the solution.
No, it's not a solution, but what Anobin does is record all the compiler flags and all the ABIs it can recognize in object files. So it's not a solution, but you're right. I hadn't thought about that. There is I don't know how far Nick is with the Anobin plugin for Clang, but he was working on that. Anobin is a plugin currently for GCC where it will output ELF nodes for all the object files in which it records all the compiler flags and ABIs it's currently respecting. And so when you link your object files together, your binaries have all the flags ever used in all the compiler versions. And he also is working on that for Clang. I don't know how far he is. It's at least an interesting thing to do. Fedora does it now distro-wide, so that you can see what is actually being used in a whole distribution, which is nice.
Mark?
I don't know whether the linker is extended. I don't know whether that work progressed to a point where the linker can reject incompatible ABIs, but it could be done in that, like it could be used to, you can use it to query the whole distribution, see what's the ABIs you're using, and I think that for versioning we could use it to validate whether the ABIs are compatible, which version are you using. I feel like that could help.
So, yeah, so I mean, if we want collaboration, or better collaboration, not to be just wishful thinking, because I think everyone is in agreement that it's a good thing to do. If we want to be pragmatic, it only happens on real projects. And I think both our communities are already collaborating on a need-be basis. I know, for example, at ARM, the LLVM and the GCC people are working, are in the same building. It was not the case for some time, but now they are all together. And we try to make sure, because ARM has an interest, that it is to have proper support for their product. And there are other cases where I think there is collaboration. So are there other projects where we could have a broader collaboration? And then, okay. Good point. So.
Yeah, I think, when I listen to this, like, I think in some cases, an RFC process, something like that, a shared way to communicate directly between like compiler developers is good. For backends, like for ABIs, I think there are already existing institutions that handle many of these things. There's like the C committee and the C++ committee. There's Dwarf. Some of those, like I know more about Dwarf, which I think is like institutionally kind of weak, that need to be strengthened, and supported by like these communities. But some of these areas, I think the ABI situation is similar. It needs a little more commitment from developers and stuff. And then some of the areas are terra incognita, right? Like linkers are not documented at all, as far as I can tell, and just work by magic. And like that would be a good thing to change and maybe create a new institution, to handle that, right? So, I don't know.
We're running just a bit short of time, so I'm going to actually draw things to a conclusion now. We've heard issues where we could do better. We've heard a willingness to do better. We've heard some concrete suggestions, mailing lists, projects that we work together, some detailed technology from Mark and Pedro, the possibility of needing new institutions. There's one other I think we've missed, which we did once. We had an LLVM cauldron the day before a GNU Tools cauldron, and 40% of the people who went to one went to the other. And that was a very good meeting, particularly the evening in between when we all came to the same reception and all drank and ate together. So my two penneth there, I think possibly we need to revive that idea. So actually we do talk to each other, because actually sometimes human interaction only matters. It does matter. I'd like to thank you all for your time. I'd like to thank our panelists for giving up their time, Arno in particular, who came up here personally just for this session. So I really do appreciate you travelling up here. Please carry on the discussion, send your feedback. If you can't find anyone else to tell, send me an email. Thank you very much.